Welcome back, everybody. We are up to lessons 8 and 9, and what these two lessons are about is something called the end behavior of a polynomial. And as it says here, at the end behavior basically tells you what happens to a polynomial as x gets infinitely positive and infinitely negative. What happens to a polynomial as x gets infinitely positive and infinitely negative? What do we mean by that? We mean what happens to y as x gets really, really large? Does y go up or does y go down? And what happens to y as x gets really, really small? So infinitely small. Does y go up or does y go down? And it turns out to figure out the end behavior of a polynomial, you only need to know two things about it. You need to know the degree, which of course we know is the largest exponent. And we also need to know the leading coefficient, the coefficient of the term with the largest exponent. So those are the only two things we need to know. Is the degree even or odd? And is the leading coefficient positive or negative? Those two things will determine the end behavior of a polynomial. Let me show you what I mean by that by looking at our examples here. So, first example, consider the polynomial y equals 2x to the fifth minus 5x to the fourth minus 30x cubed plus 5x squared plus 88x plus 60. Number one, identify the degree of the polynomial. So the degree, remember, is the highest exponent. So what is the highest exponent of this polynomial? It's x to the fifth, so this is a fifth degree. It has a degree of 5. Which of the 6 terms is greatest when x equals 0, 1, 3, and 5? Which of the 6 terms is greatest? So I set up a table down here to make it a little easier for us to figure out the answers here. If you decide that you don't want to use a table, that's fine. You do what you're comfortable with. And I'm just going to use the calculator on my phone to figure this out. So let me pull up Desmos on my phone. All right, so at x equals 0, 2x to the fifth, that's going to be 2 times 0 to the fifth. So 2 times 0, that's going to be 0. Okay? 5 times x to the fourth, so 5 times 0 to the fourth, that's also going to be 0. And it turns out all of these are going to be 0 except for this last one. The constant term is always going to have a value of 60 no matter what is. In fact, all of these are going to be 60s because the constant term is called the constant term because it stays the same no matter what the value of x is. So let's do x equals 1 now. So 2x to the fifth, so I want to do 2 times 1 to the power of 5. That's going to be 2. And then 5 times 1 to the power of 4, so that's going to be 5. This is going to be 30. This is going to be 5. This is going to be 88, because 1 to any power is 1. 3, x equals 3, so now I need to do 2 times 3 to the power of 5, and I got 486. And then next I'm going to do 5 times 3 to the power of 4. 5 times 3 to the power of 4, I got 405. Next we're going to do 30 times 3 to the power of 3, and I got 810. Okay, what's next? 5 times 3 squared, and I got 45. And then 88 times x, so that's going to be 88 times 3, and that's 264. All right, and now we're going to do the same thing, but now we're going to let x be 5. So 2x cubed, 2x to the 5th, that's going to be 2 times 5 to the power of 5. And this is the value that I got, 6,250. Up next, that's going to be 5 times 5 to the power of 4. 5 times 5 to the power of 4, so that's 3,125. All right, 30x cubed, that's going to be 30 times 5 cubed. So I'm getting 3,750. Again, I'm just using Desmos on my phone to calculate this. Next is 5x squared. 5x squared. So that's going to be 5 times 5 squared if I plug in 5. So that's 125. And then 88x is going to be 88 times 5, which is 440. So we found all those values. Now we need to identify which of the 6 terms is greatest when x equals 0. So when x equals 0, it looks like 60 is the largest term. Okay? So 60 is the largest term when x equals 0. When x equals 1, let's see, what is the largest here? This one right here. So 88x. Okay. When x equals 3, looks like this one right here, 810, so that's 30x cubed. X equals 5, let's see, 6,250. So that's 2x to the 5th. Okay. So we answered number 2. Now number 3 gets into the purpose of this lesson, and that is the end behavior of this polynomial. So remember, with the end behavior, we need to know the degree, and we need to know the leading coefficient, which I'm going to identify as LC. I'm going to abbreviate LC. So the degree we already said was 5, okay? And the leading coefficient, remember, is the coefficient of the term with the largest exponent. So the coefficient of the term with the largest exponent is 2. So my degree is 5, and my leading coefficient is 2. So how am I going to use that? Well, my degree was 5. So 5 is an odd number. So it has an odd numbered degree. My leading coefficient was 2. So my leading coefficient of 2, that's a positive leading coefficient. So I have an odd degree, and I have a positive leading coefficient. So according to this chart, this right here is my end behavior for the polynomial. So how would we describe it? We would describe the end behavior as down to the left and up to the right. That's what these arrows mean. Down to the left and up to the right. So let's write that in. So that would be, again, down to the left and up to the right. Okay? And that is how we use that chart to figure out the end behavior of a polynomial. And that is it for this lesson.